Okay, hello everyone. It is Wednesday, June 11th, 10:32 p.m. It's late. So, we're going to try to march through this single problem as fast as we possibly can. I'm not going to give it that much time before giving up if it's too hard because it is past my bedtime. So, we're going to give this one a go. So, this is LeetCode hard. Given two strings s and t of length m and n respectively, return the minimum window substring of s such that every character in t, including duplicates, is included in the window. If there is no such substring, then return the empty string. Adobe CodeBank. Okay. So just check something. Oh, oh, oh. Can use a dictionary. Now that I know order doesn't matter, then I'm chilling. I'm thinking I'll store a minimum value. course. Of course it's open. It's gonna use some sort of tricky math. 45% acceptance rate. That's stupid. Holy shit, I'm cracked. Holy fuck, I'm cracked. That is insane. First try. Okay. Maybe that one's not as hard as it seems, but sorry about being quiet. I was just kind of dialed in. I guess I'll explain my method of madness here. What I'm doing is I'm storing every single character, and then I'm storing the count for the character inside the T count array. So that will hold basically how many times that character needs to be used. So if A is inside T multiple times, it has to be used each time. And then I'm storing a thing of number of unique, which stands for the number of unique characters, and that'll basically check to see later on if we've hit every single character out. You could also kind of replace number of unique with maybe like number of uses. You know, like if like length of T. You could probably also do something like that, which is not a bad idea. But I did number of uniques elements, so that's how I did it. Basically, later on, oh sorry, let's just continue first. Then I set up a minimum string that holds, at the current state, holds the maximum value, because it hasn't been set. So we set the minimum to the maximum first because we're looking for the minimum, and then I set its string to be none because there is no minimum value just yet. And then later on we'll say, hey, if it's none, then just return an empty string, else we'll return the actual value. Okay, I set my pointers to the very left, as you do, and then I create a copy of the tcount dictionary. Honestly, I don't even need to do a copy. I could just probably use the tcount. I'll be fine, but I do it anyways. And then we do our standard sliding window approach. So just keep moving right pointer to the right. So while right pointer is currently in the array, so it's less than the length, then we can work on this function. So I'm going to basically be adding the current element that right pointer is looking at. So I grab it. I'm saying if the element is actually inside the dictionary. So if it's a usable value, it might not always be usable. If it's a usable value, then we're going to take that into account, and we're going to basically minus it from the count. If the count becomes 0, that means we've used up all of those uniques, so that unique will go down by 1. If all uniques, so if number of uniques is 0, that means we've used up all of our uniques. Ergo, that pretty much means we used up all the characters in T. If that's the case, then we're going to start our second part of this mechanism, and that is basically checking for the minimum value. So now we can track the current minimum value once we hit this. So we'll store it at the top. So basically, if the current minimum that we're holding right now is greater than the new minimum that we found, which is just right pointer versus left pointer, just the size of the substring, then we'll set the length to that, and then we'll also set the substring. And then I'm basically going to kind of pop up the left element. In order to do that, I'm going to basically check if it's a useful value or not. So if it's a value that's in our count, then I'm going to add that back. And if adding it back means I don't have enough elements, and I'm not using all my elements in T, that means count goes up. So it going back doesn't always mean that I've lost all my elements, per se, because it could actually be negative. It doesn't stop at 0, it could be negative. That is, if you had T was like a double A, and then S was a triple A. In this instance, the A count would be negative if we go through all of this. So it could move 1 to the right, and it won't use up every single unique, because it would still have that. And that still is valid. That's why we don't immediately just kind of add to the unique. And then we just move the left pointer along. And then we also just move the right pointer along. Then at the end, after everything kind of finalizes, we just return. So, yep, that was it. Quick and short, and I didn't really talk that much. Sorry about that. It's kind of dialed in, kind of sleepy. Let's go check that off. Okay, thank you for watching, and I will see you tomorrow.